So welcome to the session. So in last class, in the chapter thermodynamics, we are discussing the concept that is zeroth law of thermodynamics, and we also discussed first law of thermodynamics. Today in this class, we shall discuss some more concepts further. So what is the meaning of isothermal process and what are the conditions to obtain isothermal process? We shall see. So here isothermal, iso means same. So isothermal in that process, so it is one of the process which takes place at a constant temperature is called isothermal process. In isothermal process, there is exchange of heat between system and surrounding takes place. So isothermal change is represented by mathematical formula PV is equal to constant. So where P is pressure and V is volume. So example for isothermal process, you can quote melting of ice or you can quote boiling of water. And some of the conditions of isothermal process are, so what are the condition means? So first condition, there must be a conducting part between system and surrounding. Second one, the change should take place very slowly. Isothermal process is, it is a slow process. So that is already mentioned here. So isothermal process. So the basic definition of isothermal process is, so it is one of the process which takes place at constant temperature, and mathematically it is represented by PV is equal to constant, where P is pressure and here V is volume. And example for isothermal process, first one melting of ice and second one is boiling of water. And here one more point you have to remember. So the condition to obtain isothermal process are, first condition, there must be a conducting part between system and the surrounding, and second condition is the change should take place very slowly. So these are some of the conditions related to isothermal process. So next we shall discuss one of the important derivation. So that is, so derivation of work done in isothermal process. So here next we shall discuss one of the important derivation, that is, they may ask derive or derivation of work done in isothermal process. So this is the diagram for isothermal process. So here first you have to draw this diagram. So let us consider a cylinder which is fitted with a piston here, and this is the cylinder. Hello? Okay, is it audible? And here the cylinder, it consists of 1 mole of gas in this. So we are considering 1 mole of an ideal gas in a cylinder with non-conducting walls and perfectly conducting bottom. Cylinder is fitted with frictionless and non-conducting piston of cross-sectional area A. And here, let the gas be compressed slowly, nothing but isothermally at a temperature T. And here I am going to consider, means you have to explain the diagram initially. And after that, so from this, so you have to remember this diagram. So from this diagram, so here how we are going to represent this. So dW is nothing but work done. So let dW be the work done on the gas in the moving piston, and dx be the displacement of the piston, and dV be the decrease in the volume, and dP is increase in pressure. Therefore, Work done is given by the formula force into displacement. Symbolically, it is represented by work done as dW, force is represented as F, and displacement is represented by dx. But we know force F is equal to pressure into area. So according to this force is substituted as pressure into area here. So dW is kept as it is and dx is kept as it is. So but area into dx is nothing but increase in volume we are considering. So therefore dW is equal to P into dV. So let us consider this one as equation 1. So here after this, so first we have to explain the diagram like this. After explaining, so step by step we are deriving the expression for isothermal process. So first by drawing the diagram we have to write the given data, and after that, so work done is given by force into displacement. Mathematically it is given by dW is equal to force into dx. So force is nothing but pressure into area. So just substitute that one and remaining all the things kept as it is. And we know dW is kept as it is, pressure into area. So area into dx is nothing but increasing volume. So therefore area into dx. So this is substituted as, so that is dV. So that pressure is kept as it is. Let us consider that one as equation 1. So next step, what we are going to do is, so first after considering equation 1, so we know total work done. So how we are going to represent total work done by gas when it expands from initial volume to final volumes. So that is given by the formula. How we are going to represent? So work done W is equal to integration. We are integrating from initial to final volume. So dW is the work done. So we know. So again W is equal to integration of V1 to V2. So dW just we are substituting what we equation. So here dW already what we discussed, just substitute in place of dW. Let us consider this one as equation 1 because we know dW is equal to P into dV and already noted. So just substitute this one in place of dW. So for isothermal process of 1 mole of an ideal gas. So we know, so PV is equal to RT anta bariti. And for 1 mole, N is equal to 1 substitution. P ಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು RT divided by V ಅಂತ ತಗೊಂತೀವಿ. So ಅವಾಗ ಏನಾಗುತ್ತೆ, this equation to become, so equation to become W is equal to integration of V1 to V2. ಅದನ್ನ ಇಲ್ಲೇನಿತ್ತು ನೋಡ್ರಿ, so in place of P ಅಂತಂದಿದ್ದರೆ RT divided by V ಅಂತ substitution ಮಾಡ್ತೀವಿ. So RT divided by V into dV ಅಂತ substitution ಮಾಡಿದ್ನ. ಆಮೇಲೆ ಈ W as it is ಇಟ್ಟಿನಿ, RT ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದು ಹೊರಗಡೆ ತೆಗಿತೀನಿ, V1 into V2 as it is ಬರೀತೀನಿ. ಏನಿಲ್ಲ ಅಂದ್ರೆ 1 by V into dV ಇರ್ತೈತಿ. ಯಾಕಂದ್ರೆ R and T are constants. So next time W is equal to RT ಹೊರಗಡೆ ತೆಗೆದ್ರೆ integrate from V1 to V2 ಮಾಡಿದ್ರೆ log of V to the base E ಆಗುತ್ತೆ. So from V2 to V1. So W is equal to RT constant ಆಯ್ತಾ. So log of V ಜಾಗದಾಗ ಒಂದ್ಸಲ upper limit ಒಂದ್ಸಲ lower limit. Initial value final value substitution ಮಾಡಿದ್ರ log of V ಬದಲು ಒಂದ್ಸರಿ V2 ಹಾಕ್ರಿ ಇನ್ನೊಂದ್ಸರಿ V1 ಅಂತ ಹಾಕೊಂಡ್ರಿ. So substitution ಮಾಡಿದ್ಮೇಲೆ W is equal to RT log of V2 divided by V1 ಅಂತ ಆಗುತ್ತಾ. But ನಮಗೆ ಗೊತ್ತೈತಿ ಏನ log of x to the base 3 ಅಂದ್ರೆ ಅದರ ವ್ಯಾಲ್ಯೂ 2.303 log of x to the base 10 ಆಗುತ್ತೆ. Therefore W is equal to ಇದೇನಾಗುತ್ತಾ ಇಲ್ಲಿ ಏನಾಗ್ತೀನಿ ನಾನು log of x ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀನಿ 2.303 RT log of V2 by V1 to the base 10 ಆಯ್ತು. Similarly ಅದೇ ತರ ಇದು similarly symbol W is equal to 2.303 RT log of in terms of pressure to the base 10 V2 by V1 ಅಂತ ಅಂತೀವಿ. ಯಾಕಂದ್ರೆ P is directly proportional to B at constant temperature. So where V1 and V2 are the pressures of gas corresponding to the volume V1 and V2. So first na ಏನು ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ. So ನಾವು already work done dW is equal to force into displacement, dW is equal to P into dV ಅಂತ ತಗೊಂಡಿವಿ. ಹಂಗಂದ್ರ ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಿವಿ ಟೋಟಲ್ ವರ್ಕ್ ಅನ್ನ is given by when gas expands from initial volume V1 to final volume V2 ಅಂತ. So ಅದನ್ನ initial volume integrate ಮಾಡ್ತೀವಿ V1 to V2 ಅಂತ ತಗೋತೀವಿ. So W is equal to integration of V1 to V2 dW. dW ಅಂದ್ರೆ P into dV ಅಂತ ಹಿಂಗಡೆನೆ equation 1 ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ substitution ಮಾಡಿ. For isothermal process for 1 mole ಇದ್ದಾಗ PV is equal to NRT, N ಬದಲು 1 ಅಂತ substitution ಮಾಡ್ತೀವಿ. So ಅವಾಗ ಏನಾಗುತ್ತೆ P is equal to RT divided by V ಆಯ್ತು. So ಇದಾದ ನಂತರ equation 2 ಏನಾಗ್ತೈತಿ work done is equal to integration of V1 to V2 ಅಲ್ಲಿ RT divided by V ಅಂತ substitution ಮಾಡ್ತೀವಿ. P ಬದಲು RT divided by V ಅಂತ into dV as it is ಇರ್ತೀವಿ ಮುಂದಿನ equation ಅಂತ ತಗೊಳ್ರಿ. So RT constant ಇತ್ತು ಹೊರಗಡೆ ತೆಗೆದೀನಿ integration of 1 by V into dV ಉಳಿತೈತಿ. It is integrated from V1 to V2. V1 ಅಂದ್ರೆ initial volume, V2 ಅಂದ್ರೆ final volume. R ಮತ್ತು T ಅಂತ ಕಾನ್ಸ್ಟೆಂಟ್ RT ಹೊರಗೆ ತೆಗೆದೆ 1 by V ಅಂದ್ರೆ log of V to the base E. ಆವಾಗ ನಾವು ಅದನ್ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ಅದನ್ನ ಈ ತರ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರ್ತೀವಿ V1 ಮತ್ತು V2. So log of ಒಂದ್ಸಲ upper initial volume ಒಂದ್ಸಲ lower limit ಹಾಕ್ತೀವಿ. So log of V2 minus of log of V1 ಅಂತ RT log of V2 minus of V1 ಅದು ಫಾರ್ಮುಲಾ ಪ್ರಕಾರ log of V2 by V1 ಅಂತ ಆಗುತ್ತೆ. So log of x to the base e value 2.303 log of x to the base 10 to the base e ಇದನ್ನ to the base 10 ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಅದು multiplied by 2.303 log x to the base 10 ಮಾಡ್ತೀವಿ. ಯಾವಾಗ ಏನಾಗುತ್ತೆ W is equal to log of x to the base e to the base 10 ಮಾಡಕ್ಕೆ multiplied by 2.303 ಮಾಡ್ತೀವಿ. RT log of V2 by V1 ಅಂದ್ರೆ to the log of to the base e ಇದನ್ನ to the base 10 ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ಕೆ multiplied by 2.303 ಅಂತ ಮಾಡಿದ್ವಿ. ಅದಾದ್ಮೇಲೆ ಸಿಮಿಲರ್ಲಿ in terms of pressure ಇತ್ತಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಬದಲು ಪ್ರೆಷರ್ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ. ಸೊ W is equal to 2.303 RT log of P2 by P1. V1 ಮತ್ತು V2 ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ವಾಲ್ಯೂಮ್ ಮತ್ತು ಫೈನಲ್ ವಾಲ್ಯೂಮ್. P1 ಮತ್ತು P2 ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ಮತ್ತು ಫೈನಲ್ ಪ್ರೆಷರ್ ಅಂತ ಅರ್ಥವ. So this is one of the important derivation. So definitely they will ask for 5 marks. Try to practice this one. Derive an expression for isothermal process ಅಂತ ಕೇಳಬಹುದು. So next we shall discuss about adiabatic process. So we shall see what is the meaning of adiabatic process. So adiabatic process is nothing but here adiabatic process andreno isothermal process nodidra. Next adiabatic process. So adiabatic process, the meaning of adiabatic process is adiabatic process andreno. So some of the examples for adiabatic process, and mathematically it is represented as, how we are going to represent, let us see, and some of the conditions for to obtain adiabatic process, what are the conditions we shall see. And some of other examples for adiabatic process are, what are they, we shall discuss. So adiabatic process is nothing but it is one of the process in which there is no exchange of heat between system and surrounding. So adiabatic process, mathematically it is represented by PV raised to gamma is equal to constant ಅಂತ represent ಮಾಡ್ತೀವಿ. Where gamma is equal to, it is the ratio of specific heat at constant pressure to the specific heat at constant volume. Specific heat at constant pressure and the Cp ಅಂತ ತಗೊಂತೀವಿ, specific heat at constant volume of the Cv ಅಂತ represent ಮಾಡ್ತೀವಿ. And example for adiabatic process is sudden expansion or sudden compression of gas. And what are the conditions to obtain adiabatic process means? So first condition, there must be no conducting path between system and surrounding material. Second one, change should take place very rapidly. Adhe no isothermal process, it is a slow process ಆಗಿತ್ತು. But adiabatic process, it takes very fast, means rapidly. And some other example for adiabatic process yavanandra. So first one, during pumping, the bicycle tube or the barrel of pump is heated. Yaka? So why? Because, so here some other example for adiabatic process. First one, during pumping a bicycle tube, the barrel of pump is heated. Yaka? This is because work done in increasing the pressure is converted into heat. So heat is unable to go out of the barrel in a shorter time. So second one example in Kolbodu. So bursting of air-filled tube, when the bicycle tube bursts, the air coming out of the tube expands rapidly into the atmosphere and gets cooled isothermally. And adiabatic change also represented by the equation like this. So some other example of adiabatic process are, so they can be represented like this. So some other examples of adiabatic process are, first one, during pumping, bicycle tube or barrel pump is heated because work done in increasing the process is converted into heat. So this heat unable to go out of the barrel in a short time. And second example, bursting of air-filled tube, when the bicycle tube bursts, air coming out of the tube expands rapidly into the atmosphere and gets cooled isothermally. And here, adiabatic change can also be represented as TV raised to gamma minus 1 is equal to constant, or it can also be represented as Tp raised to gamma minus of 1 is equal to constant. This is in terms of volume, or this is in terms of pressure. So this is all about. So what is the meaning of adiabatic process? Some of the condition of adiabatic process and some of the example of adiabatic process. So next we shall derive one of the important expression for adiabatic process. Let us see that one. So here we know adiabatic process. In order, ಯಾವ question ಕೇಳಬಹುದು ಅದನ್ನ ಅಂತಂದ್ರೆ, so they may ask a question like this also. Derive work done in adiabatic process ಅಂತ ಕೇಳಬಹುದು. ಸೊ ಅದನ್ನ ಆ ತರ ಕೇಳಿದಾಗ first you have to draw this diagram. So we are considering the cylinder which is fitted with piston and it consists of 1 mole of ideal gas. Same in the consider ಮಾಡ್ತೀವಿ. So ನಾವು ಏನು ಮಾಡ್ತೀವಿ? So we are considering 1 mole of an ideal gas. So first we are considering ಏನು ಮಾಡ್ತೀವಿ? In order to derive the adiabatic expression for work done in case of adiabatic process, we are considering the cylinder which is fitted with piston. In that we are considering 1 mole of an ideal gas in a cylinder with non-conducting wall and bottom. So cylinder is fitted with frictionless and perfectly non-conducting piston of cross-sectional area A anta ತಗೊಂಡಿವಿ. So let gas be compressed suddenly andra adiabatically anta ತಗೊಂತೀವಿ. dW is nothing but work done on the gas in the moving piston. So next, so from this diagram, so dV andrenu decrease in volume. So what is the meaning of dV? So dV is nothing but decrease in volume. And next, dP is nothing but increase in pressure. And dT is nothing but increase in temperature. So work done is given by the formula. In case of adiabatic process, work done is given by force into displacement under dx. So work done under dW ಅಂತಲೂ represent ಮಾಡ್ತೀವಿ. That's equal to F into dx. So ನಮಗೆ ಗೊತ್ತೈತಿ force ಅಂದ್ರೆ ಏನು? Nothing but pressure into area. So force is nothing but ಏನಂತ ತಗೊಂತೀವಿ? Force is equal to pressure into area. So F ಇಲ್ಲಿ force ಅಂದ್ರೆ ಏನಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ? dW is equal to pressure into area. So pressure into area ಅಂದ್ರೆ ಏನು? Force ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ. ಈ dx ಅನ್ನ as it is ಇಟ್ಟಿನಿ. So next ನಮಗೆ ಗೊತ್ತೈತಿ ಏನ? dV is nothing but area into dx. So ಅದಕ್ಕೋಸ್ಕರ ಈ area into dx ಅನ್ನ ಏನಂತ CP as it is ಇಟ್ಟಿನಿ. area into dx ಅನ್ನ ಏನಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬಹುದು? dV ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬಹುದು. ಈ dW as it is ಇರುತ್ತೆ. So let us consider this one as equation 1. So next total work done ಹೆಂಗ್ ಮಾಡ್ತೀವಿ ಅದನ್ನ? Next total work done on the gas when it is compressed from initial volume V1 to final volume. So ಅದನ್ನ ಹೆಂಗ್ represent ಮಾಡ್ತೀವಿ? So that is represented as W is equal to integration of V1 to V2 integration of dW. ಇದನ್ನೇ ಯಾವ ತರ ಮಾಡಬಹುದು? integration of V1 to V2 dW ಅಂದ್ರೆ P into dV ಅಂತ represent ಮಾಡಬಹುದು. So let us consider ಯಾಕಂದ್ರೆ ನೋಡ್ರಿ dW ಅಂದ್ರೆ ಏನೈತಿ? P into dV ಇದನ್ನೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. So next for adiabatic process of 1 mole of an ideal gas ನಾವು ಯಾವ ತರ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು? PV raised to gamma is equal to constant ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. So ಅದನ್ನ ಹೆಂಗೆ ಬರೀತೀವಿ? P is equal to C divided by B raised to gamma. ಇದು equation 3 ಅಂತ ತಗೊಳ್ಳೋಣ. So next put this equation 3 in equation 2. So then W is equal to integration of V1 to V2 C divided by B raised to gamma into dV ಅಂತ ಬರೀತೀವಿ. ಈ W as it is ಇರ್ತೀವಿ. C ಅಂದ್ರೆ ಕಾನ್ಸ್ಟಂಟ್, V1 to V2 ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ ಇದು 1 divided by V raised to gamma into dV. R and T ಏನವು ಕಾನ್ಸ್ಟಂಟ್ ಅವು. ಸೊ ಇದನ್ನ ಹೆಂಗೆ ಬರೀಬಹುದು? ಈ W as it is ಇರ್ತೀವಿ, C ಹೊರಗಡೆ ಹಾಕಿದಾಗ ಸೊ V raised to 1 by V ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ V raised to minus gamma plus of 1 divided by minus of gamma plus of 1. ಅದನ್ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ಇದನ್ನ V1 ಮತ್ತು V2 ನ ಈ ತರ ಬರೀತೀವಿ. ಅದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ನೋಡ್ರಿ, W is equal to C divided by 1 minus gamma ಹೊರಗಡೆ ಹಾಕಿದ್ರೆ ಇದನ್ನ ಯಾವ ತರ ಬರೀಬಹುದು? V2 raised to minus gamma plus of 1 minus of V1 raised to minus gamma plus of 1 ಅಂತ ಬರೀತೀವಿ. So next W is equal to 1 minus of 1 minus gamma ಯಾಕಂದ್ರೆ C ನ ಒಳಗಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ C into V2 raised to minus gamma plus of 1 minus of C into V2 raised this is V1 raised to minus gamma plus of 1 ಅಂತ ಆಯ್ತು. ಸೊ ನಮಗೆ ಗೊತ್ತೈತಿ ಏನಾ? C is equal to PV raised to gamma implies P1 V1 raised to gamma is equal to P2 V2 raised to gamma ಅಂತ ತಗೋತೀವಾ. ಸೊ ನೆಕ್ಸ್ಟ್ W is equal to 1 minus of gamma ಒಳಗಡೆ ಅದು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ P2 raised to gamma V2 raised to gamma minus 1 minus of P1 V1 raised to gamma V1 raised to minus gamma plus of 1 ಅಂತ ತಗೋತೀವಿ. ಸೊ W is equal to ಇದೇನಾಗ್ತೈತಿ? ಸೊ ಅಪೋಸಿಟ್ ಸೈನ್ ಇದ್ದಿದ್ದು ಏನಾಗ್ತದೆ? ಕ್ಯಾನ್ಸಲ್ ಆಗಿ P2 into V2 minus of P1 into V1 divided by 1 minus gamma ಅಂತ ಆಗ್ತೈತಿ. ಅದಾದ್ಮೇಲೆ V ನೋ ಏನ್ ಗೊತ್ತೈತಿ ನಮಗ? We know what we know, but P1 V1 is equal to R P1 ಅಂತ ಗೊತ್ತೀವಾ, and P2 V2 ಅಂದ್ರೆ ಏನಂತ ತಗೊಂತೀವಿ? R P2 ಅಂತ ತಗೊಂಡ್ವಿ. ಸೊ ಅವಾಗ ವರ್ಕ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ P1 V1 ಇದ್ದಲ್ಲೇ R T2, P2 V2 ಇದ್ದಲ್ಲೇ R T1 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ divided by 1 minus of gamma ಅಂತ ಕೊಡ್ತೀವಿ. ಸೊ W is equal to R ಅಂದ್ರೆ ಕಾನ್ಸ್ಟಂಟ್ ಐತಿ, T2 minus of P1 divided by 1 minus of gamma. So W is equal to R constant ಐತಿ, T1 minus of T2 whole divided by gamma minus of 1. So for 1 mole of ideal gas equal for n moles ಗೆ so ಹೆಂಗ್ ಬರೀತೀವಿ? work done is equal to nRT ಅಂತ ಬರೀತೀವಿ. ಇದು ಬ್ರಾಕೆಟ್ ಒಳಗೆ T1 minus of T2 whole divided by gamma minus of 1 ಅಂತ ತಗೋತೀವಿ. So this is the final expression ಅಂತ ಆಗ್ತೈತಿ. So ನಾವು ಏನು ಮಾಡಿದ್ವಿ ನೋಡ್ರಿ, first we considered what we considered. So we considered this diagram in order to derive an expression for ideal gas, and after considering you have to explain this one in your own words. And after that, so what we did for adiabatic process, what we did? So for adiabatic process, we know for 1 mole of an ideal gas, P is equal to C divided by V raised to gamma ಅಂತ ತಗೊಂಡ್ವಿ. So let us consider this equation 1. Equation 3 is substituted in equation 2. Our work done is equal to C divided by V raised to gamma into dV. It is integrated from V1 to V2. V1 and initial volume, V2 and the final volume. So C another constant that we integrate ಮಾಡಕ್ ಬರಲ್ಲ. So we remove that one outside. remaining 1 divided by v raised to gamma into dv. So from that r and t are the constant ಇರುತ್ತೆ. Integration of 1 by v ನ integrate ಮಾಡಿದ್ಮೇಲೆ v raised to minus gamma plus of 1 whole divided by minus gamma plus of 1 ಆಗುತ್ತೆ. ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ಮೇಲೆ ಅದನ್ನ ಸೈಡ್ ಅಲ್ಲಿ v1 v2 ಬರೀತೀವಿ. So after that w is equal to c ಅಂದ್ರೆ ಕಾನ್ಸ್ಟಂಟ್ 1 minus of gamma ಹೊರಗಡೆ ತೆಗಿತೀವಿ. ರಿಮೈನಿಂಗ್ ಆ v raised to minus gamma plus 1 ಇದ್ದಲ್ಲಿ ಒಂದ್ಸಲ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಹಾಕ್ತೀವಿ, ಒಂದ್ಸಲ ಲೋವರ್ ಲಿಮಿಟ್ ಹಾಕ್ತೀವಿ. ಒಂದ್ಸಲ v2 ಹಾಕಿ ಒಂದ್ಸಲ v1 ಹಾಕಿದಾಗ ಆಮೇಲೆ ಆ c ಒಳಗಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ 1 divided by 1 minus gamma in the bracket c v2 raised to minus gamma plus of 1 minus of c into v1 raised to minus gamma plus of 1 ಆಗುತ್ತೆ. ನಮಗೆ ಗೊತ್ತಿದೆ c ಅಂದ್ರೆ ಏನು, pv raised to gamma, ಅದನ್ನ p1 v1 raised to gamma is equal to p2 v2 raised to gamma ಅಂತ ಬರೀಬಹುದು. So w is equal to 1 divided by 1 minus gamma. ಒಳಗಡೆ ನೋಡ್ರಿ p1 v1 ಆಮೇಲೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತೈತಿ. ಸೊ p1 v1 is equal to p2 v2. ಸೊ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ v2 as c ಅಂದ್ರೆ ಏನ p2 v2 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. ಅಗೇನ್ ಇಲ್ಲಿ c ಅಂದ್ರೆ ಏನ p1 v1 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ವಿ. ಯಾವ ತರ, ಸೊ ಒಂದ್ಸಾರಿ ಇಲ್ಲಿ ನೋಡಿ ತೋರಿಸ್ತೀನಿ ನೋಡಿ. ಇಲ್ಲ c ಅಂದ್ರೆ ಏನೈತಿ p1 v1 ಐತಾ. ಸೊ ಅಗೇನ್ c ಅಂದ್ರೆ ಏನ p2 v2 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬಹುದಾ. ಸೊ ಈ v2 ನ ಆಸ್ ಇಟ್ ಇಸ್ ಐತಿ. ಸೊ ಇಲ್ಲಿ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ c ಅಂದ್ರ ಸೊ ಈ p2 v2 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. ಈ v2 ಆಸ್ ಇಟ್ ಇಸ್ ಇಟ್ಟಿವಿ. c ಅಂದ್ರೆ ಏನ p1 v1 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. ಸೊ ಅಪೋಸಿಟ್ ಸೈನ್ ಇದು ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ w is equal to p2 v2 minus of p1 v1 divided by 1 minus gamma ಆಗುತ್ತೆ. ಸೊ ಈ ಸ್ಟೆಪ್ ಆದ್ಮೇಲೆ ಸೊ ನಮಗೆ ಏನ ವಾಟ್ ವಿ ನೋ ಈಸ್ p1 v1 ಅಂದ್ರೆ rt1 ಅಂತ ಹಾಕೋಬಹುದು, p2 v2 ಅಂದ್ರೆ rt2 ಅಂತ ಹಾಕೋಬಹುದು. ವಿ ನೋ ದಟ್. ಸೊ ವರ್ಕ್ ಡನ್ ಅನ್ನ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ ಇಲ್ಲಿ ಏನಂತ ತಗೊಂಡಿವಿ, ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ p2 v2 ಇದ್ದಲ್ಲಿ ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬಹುದು rt2. ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ p1 v1 ಇದ್ದಲ್ಲಿ rt1 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಡಿವೈಡೆಡ್ ಬೈ 1 minus gamma as it is ಐತಿ. ಸೊ ಎರಡರಲ್ಲಿ r is constant, universal gas constant ಹೊರಗಡೆ ತೆಗಿತೀವಿ. t2 minus of p1 divided by 1 minus gamma as it is ಬರ್ತೀವಿ. work done is equal to r ಅಂದ್ರೆ universal gas constant ಅದನ್ನ t1 minus of t2 divided by gamma minus of 1 ಅಂತ. for n number of moles ಇದ್ ಬಂದ್ರ ಅದನ್ನ ಮಾಡ್ತೀವಿ multiplied by n number of moles n ಐತಿ. so w is equal to n r in bracket t1 minus of t2 divided by gamma minus 1. this is the final equation now to represent the work done in case of a adiabatic process. Derive expression for work done in case of adiabatic process and question ಕೇಳಿದಾಗ so you have to derive up to this. Definitely they will ask for 5 marks this one. Please try to practice this one. So work done in case of isothermal discuss ಮಾಡಿದ್ವಿ, work done in case of adiabatic process ಅನ್ನ discuss ಮಾಡಿದ್ವಿ. So next we shall discuss about so what is the meaning of reversible ಮತ್ತು irreversible ಅನ್ನೋದನ್ನ discuss ಮಾಡೋಣ. So next we shall discuss about reversible and irreversible process. So here the meaning of reversible process is, so reversible process andrena and irreversible process andrena let us discuss. So here reversible process, reverse a word alle gottagtiti. The meaning of reversible process is, and example for reversible process, and next we shall discuss about meaning of irreversible process and example for irreversible process, and next we shall discuss what is the meaning of heat engine. And here we know reversible process antandreno, it is one of the process in which all the changes occurred in a direct process and they can possible to reverse itself. Example hen kodabodu reversible process andra A very slow expansion or very slow compression of a gas is one of the example for reversible process. ಹಾಗಂದ್ರೆ irreversible process ಅಂದ್ರೆ ಏನು? ಅದನ್ನ ವಾಪಸ್ ನಾವು process ಅನ್ನು ರಿವರ್ಸ್ ಮಾಡಕ್ಕೆ ಬರುವುದೇ ಇಲ್ಲ, ಅದಕ್ಕೆ irreversible process ಅಂತ ಕರಿತೀವಿ. So it is the process in which all the changes occurred in the direct process cannot be exactly reversed. ಹಾಗೆ reversible process ಒಳಗೆ ರಿವರ್ಸ್ ಮಾಡಬಹುದು, irreversible process ಒಳಗೆ ರಿವರ್ಸ್ ಮಾಡಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. Example ಏನು ಕೊಡಬಹುದು? Sudden expansion or sudden compression of gas is example for irreversible process. And next we shall see what is the meaning of heat engine. That is one of the device that converts heat energy into mechanical work ಆಗಿ convert ಮಾಡೋದಕ್ಕೆ heat engine ಅಂತ ಕರಿತೀವಿ. So that is one of the device in that heat energy is useful in order to convert mechanical work. So that is the meaning of heat engine ಅಂತ ಕರಿತೀವಿ. And here, next we shall see construction of carnot engine motor. So first construction of carnot engine is, so yavara it consists of different parts. So note, so this is carnot engine. Now to show the carnot engine, so this is the diagram we are showing. So here carnot engine, so it consists of different parts. So construction of carnot engine, it consists of different parts like cylinder, and second one is a source which is maintained at temperature T1, and third one sink which is maintained at a temperature T2. So note, it consists of carnot engine is it consists of different parts. Let us discuss the construction of carnot engine and how it is made up of, and one by one discuss one. So first we shall discuss about carnot engine. So carnot engine ಅಂದ್ರೆ ಏನು? So we shall discuss about construction of carnot engine. It consists of different parts like cylinder, source, sink, and insulating stand. So source is maintained at temperature T1 and sink is maintained at temperature T2. So we shall discuss the working process of different parts like cylinder, source, sink, and insulating stand. So based on this they will ask, so explain construction of carnot engine and you have to draw all this diagram and you have to explain one by one. So what is the process which is involved in that explain one by two. So we shall discuss one by one. So here first we shall discuss first part, that is cylinder. So cylinder is the first part. Cylinder is made up of, first we shall discuss about first one, so that is cylinder. So cylinder is made up of perfectly non-conducting wall and conducting base. So it is fitted with non-conducting and frictionless piston. It consists of a perfect gas as a working substance. So second idರಲ್ಲಿ source ಅಂತ ತಗೊಂತೀವಿ, which is maintained at a temperature T1 Kelvin. So it is a hot body. Source ಬಗ್ಗೆ explain ಮಾಡ್ತೀನಿ. It is a hot body of infinite thermal capacity. So it can supply any amount of heat at constant higher temperature, which is maintained at temperature T1 Kelvin. So the working substance drawn heat from the source again and again, but its temperature remains constant till delay. So which is maintained at temperature T1 Kelvin. So next, working of sink noda. So working of sink ಏನಂದ್ರೆ, so this is cold body and this is hot body ಅಂತ ಕರಿತೀವಿ. So here sink we call that one as cold body. ಯಾಕಂದ್ರೆ it is a cold body of infinite thermal capacity. It can absorb any amount of heat at constant lower temperature, which is maintained at temperature T2 Kelvin. Working substance reject heat to the sink again and again, but temperature remains constant here. And fourth part, that is insulating stand. So this is insulating stand, this is sink, this is source, and this is cylinder. So here insulating stand explain madbekandre, it is a non-conducting stand used to place cylinder on it anta karithivi. So here this is all about construction of carnot engine. So sometime 5 marks ಕೇಳಿದಾಗ first you have to draw the diagram and you have to explain one by one, that is cylinder, source, sink and insulating stand ಬಗ್ಗೆ explain ಮಾಡಬೇಕು. So next we shall see so the schematic. So this is one of the diagram used to represent schematic diagram of heat engine. ಯಾವ ತರ represent ಮಾಡ್ತೀವಿ? So schematic diagram of heat engine. So that is represented as like this. So this is the schematic diagram of heat engine. So it consists of hot reservoir which is maintained at temperature T1 and cold temperature reservoir which is maintained at T2. So external work done in a W1 ತಗೊಂತೀವಿ. So here working substance. So this is the working substance. And here efficiency of heat engine. ಅದನ್ನ ಯಾವ ತರ represent ಮಾಡ್ತೀವಿ? ನೀಟಾ in terms of heat engine is ಯಾವ ತರ define ಮಾಡ್ತೀವಿ? Efficiency of heat engine is represented as it is the ratio of output work to the heat engine ಅದನ್ನ represent ಮಾಡ್ತೀವಿ. So mathematically efficiency of heat engine in terms of heat engine is given by neta is equal to output work divided by heat supply. Output work ಅಂದ್ರೆ W, heat supplied under Q1. So W1 is nothing but Q1 minus of Q2 whole divided by Q1. So this is the formula used to represent efficiency of heat engine in terms of the heat energies. So output work under W1 represent ಮಾಡ್ತೀವಿ, heat supplied under Q1 ಅಂತ represent ಮಾಡ್ತೀವಿ. W1 ಏನಂತ represent ಮಾಡಬಹುದು? That is nothing but Q1 minus of Q2 Q1 as it is bರುತ್ತೆ. So this is efficiency of heat engine. Mathematically it is represented by like this. So this is one of the schematic diagram of heat engine. So that is represented like this way. Q1 ಅಂದ್ರೆ ಏನಿದೆ? So nothing but so Q1 ಅಂತಂದ್ರೆ amount of heat supplied by source. Amount of heat supplied by source ಅಂತ ತಗೋತೀವಿ. Q2 ಅಂದ್ರೆ amount of heat rejected to the sink. W is nothing but Q1 minus of Q2 ಅಂದ್ರೆ that is nothing but work done. T1 ಅಂದ್ರೆ temperature of source, T2 ಅಂದ್ರೆ temperature of sink. So here one more point you have to remember. So that is related to so here we have to remember these note points. So this you have to remember. This is very important. So consider the relation beta is equal to T2 minus of T1 whole divided by T1. So first point what you have to remember is, so here if the relation consider beta is equal to T1 minus of T2 divided by T1 ಅಂತ ತಗೊಂತೀವಾ. So let us consider that one as equation 1, efficiency. So if T2 temperature is 0 Kelvin itandra neta is equal to 1, that is efficiency is nothing but 100% ಅಂತ ನೆನಪಿಟ್ಕೋಬೇಕು. If 0 Kelvin cannot be so realized in practice andra hence efficiency of engine cannot be never be 100%. So in other words complete conversion of heat into work is impossible. So neta is always less than 1 ಅಂತ ನೆನಪಿಟ್ಕೋಬೇಕು. Second condition, if T1 is equal to T2 ಇತ್ತಂದ್ರ So neta is equal to 0. And the conversion of heat into work is not possible when the temperature of source is equal to the temperature of the sink iddaga. Hence, to convert heat into work, there must be two bodies or at different temperatures. So for third point, for greater efficiency, T1 is far greater than T2. So according to equation 1 prakara, efficiency of carnot engine yavalu less than 100% irutte. That we have to remember. And real engines are subjected to practical difficulties such as friction, loss of heat due to conduction. Hence, they are less efficient than the carnot engine. These points we have to keep in your mind. So this is important thing. And these conditions we have to remember.